Okay, I forgot to unmute myself online. Okay, let's start today's lesson. Hi everyone, I'm Miss Eileen. I'm one of the A-Math teachers with OVERMUGGED. So welcome to session 2 of the Sec 3 A-Math revision at the Bukit Timah branch. So yeah, for those of you online, we're actually having physical lessons at our Bukit Timah branch today. So yeah, if there's any time you guys cannot hear me online or cannot see the screen, just write down in the chat box. It might be because I accidentally mute or stop sharing the screen. Okay, just a brief introduction. Yeah, this is me. I am very awkward, my picture is there, but okay. I am with OVERMUGGED, I'm a secondary school IP and JC math tutor. I specialize in teaching O-level A math and IP A math. So I'm not just some random teacher that, just started teaching, okay? I have some qualifications over here, okay? So whatever I teach can be trusted lah, okay? So make sure you listen carefully and listen out for the tips and tricks taught during the lesson and apply for your apply it during your examinations and when you're doing any of your schoolwork. Okay, and yeah, more of my qualifications, but the main thing on this page is I just want to let you guys know that math is fun, okay? Don't think that math is an intimidating subject. I know that a lot of you will be like, what? Like, what's going on? Math is not fun, it's so difficult. But seriously, once you, especially for A math, okay, once you get the logic behind it, you'll realize that all the questions are about the same. So you just need to keep applying the same logic, but at the same time also make sure you're not just, memorizing the answers. Understand the logic, apply the same concept that you already learned well, and you'll realize that all the questions are generally super similar. So you'll be able to get it. And once you start doing well, you'll start liking the subject, because who doesn't like a subject that they do well in? Okay, it's like that one. So, and don't be shy to ask questions. I'll be giving you guys opportunities to ask me questions during the lesson. So, feel free to, type in the chat box for those online, and, those physically can just raise up your hand to let me know. Okay, asking questions is really important. I don't want you guys to, walk out of the classroom being more confused than when you enter. All right. Okay, don't need to be shy. So, overview of today's lesson. So today we'll only be covering trigonometry because unfortunately we have slightly less than 2 hours, and trigonometry is a very big subject and there's a lot of details you need to know in trigo. There's a lot of different questions that you have to make sure you know how to tackle each of them separately using the different logics. Okay, so the key takeaway for today's revision lesson is for you to, understand and, be better at grasping the key concepts and make sure you avoid common mistakes that you maybe have already did it before or you see your friends do it before. And today, I also will help you guys identify common type of questions and, the basic strategies to tackle them. So you'll realize that I will keep repeating this question will keep appearing, that kind of thing. So when I say that, it means that you will definitely see this kind of questions in at least one of your exams in the future. So make sure you know how to tackle those questions. And I'll also be teaching some checking and memorization tips, to help you make sure you are answering the questions accurately. Because more often than not, right, some of you guys are already maybe very good at the subject. Okay, you understand what you're doing, but you are not, a lot of people, I mean not a lot of people, some of you guys already know how to do the question, but you might not be able to realize that, actually my answer, there's a careless mistake here and there. So this these checking tips, right? When you look at the answer, you just need to do certain checks and you realize that, actually there's a careless mistake somewhere. So you'll be able to identify that your answer is wrong and you probably need to check back on your steps to find out where is your mistake. Okay, Trigo, this chapter, there are many ways for you to check your work and there's many opportunities for you to check your work. So make sure you utilize this opportunity to make sure that your answers at the end of the day is 100% correct. Okay, so yeah, just an exam countdown for those of you who attended session 1. I mentioned this before. You only have about 1 month to your EOY. Okay, luckily your Sec 3 is not O-level yet, not that intense, but 1 month, right? You should spend the next 2 weeks revising on your key concepts, not just for trigo, for every single topic that you have learned so far, from quadratic curves all the way to trigo. And for the 2 weeks before your exam, you should force yourself to do practice papers. It's quite irritating, I understand, like who will want to keep doing, exam papers again and again and again. But math is like that. The more practice you do, the better you'll become. Because with more practice, right, you will realize that the questions that appear are more or less the same. You will be able to recognize such questions, and then you also be able to see that, actually this question I do something similar before. So you apply the same things that you have written before, and you realize that actually it's the same one. The concept is the same. You just need to maybe tweak a bit to help you get the answer for this new question. Okay, so let's begin with today's lesson. So please make sure for those online, you have downloaded session 2. Okay, session 2 is the cone-shaped thingy at the front. Session 1 was a donut. Okay, so make sure you download the correct one. We will only be covering Trigo today. Okay, and yep, meet the math team. Feel free to read this paragraph on your own. But the most important thing here is this QR code over here. Okay, this QR code contains a few math resources. Feel free to use them. It's like free for the public lah. So if you want any practice questions, go ahead and maybe source them from this QR code. But take note that there might not be answers to the questions. Okay, a common question is after our end of year event, a lot of students will ask, oh, will the answers be uploaded? No promises for now, because we ourselves, we don't have the answer key. So if we manage to, have the time to come up with all the answers for the supplementary questions, we will upload them, but no promises, because we also need to write out the answers on our own and we don't really have the time. Okay, but I will be going through some supplementary questions today. So feel free to take a screenshot or screen capture if you need to when I'm going through the questions. Okay, these are the contents. Just read the content page on your own. But basically today we are just going to be covering Trigo, the whole chapter. So some of you might not have finished covering Trigo in school. So if any time, it seems a bit too fast or too confusing, let me know. Okay, because I know some of you might not have completed the whole chapter, but today we will be looking at the whole chapter for Trigo. So these are the syllabus outline. Read if you need to. Okay. If I'm going too fast or too slow, let me know. And then we'll start off with the content. Okay, the first page, 1.1. This one, nothing new. You have already learned this in probably Sec 2. Okay, your tuakaso. Do remember this acronym, tuakaso is very important. So tangent is opposite over adjacent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. This logic is very important. You will keep seeing this even in A Math Trigo. Something to take note. A Math Trigo will never appear in E Math, but E Math Trigo can appear in A Math Trigo. So please make sure you have a good understanding on what E Math Trigo is about first. Like, you learn cosine rule, sine rule in E Math, right? These rules might come out in an A Math question. Okay, we don't have any questions today that you'll see this, but don't be flustered if you see E Math in A Math. It can happen. Okay, but you will never see A Math in E Math. Another thing that is not in your notes, okay, but you all should know, pi, okay, pi radian is equals to 180 degrees. Radian, right, and degrees are basically measurements for an angle. It's just like meters and kilometers. They are measurements for distance, right, or length. But, for degree, we have radian and pi. A lot of students, they very confused. They know that, pi radian is equals to 180 degrees. But when the question gives them, like, for example, 5 degrees, convert it to radian, that's where they get confused. Like, how am I going to convert it? You just tell yourself, you always just need to remember this. Okay, pi radian equals to 180 degrees. So how do I get 1 degree? Okay, how do I get 1 degree? I just divide both sides by 180 lor. So 1 degree is pi divided by 180, and we get pi over 180 radian. Okay, so 1 degree is equivalent to this in radian units. Then same thing, if you need 5 degrees instead and you want to convert it to radian, you just times 5. So this side also times 5. Okay, this is the logic. So there are students who struggle to convert between degree and radian. So what I'm trying to say here is don't need to struggle. So long as you remember these, right, and you divide and multiply both sides accordingly, you will be able to convert from radian and degrees successfully. So same thing, if you want 1 radian, you divide both sides by pi so that you can get 1 radian on this side. So it will be 180 degrees divided by pi. So 1 radian is equals to this much degree. Then if you want 5 radian, you just times 5 on both sides. Okay. Coming to the next part. Okay, your reciprocal ratios. This one you should also know by now. It's pretty straightforward. It's just the reciprocal of sine, cosine, and tangent respectively. Just take note, sometimes in exam you might see this, okay? CSC is exactly the same, it's equivalent to cosecant. So when you see CSC, don't be flustered again. It's just saying cosecant, okay? Then memorization technique, yeah, just look at the third letter. But for CSC, cannot, you just tell yourself this one is cosecant, therefore it is 1 over sine. Okay, so now let's look at principal values. Some of you might be wondering, what are principal values? Like, what's going on? Okay, there's a typo, by the way. Your note should see a theta here. Okay, it's not a theta. It's not supposed to be a theta. It's supposed to be a K. Okay, it's supposed to be a ratio. Theta is an angle. K is a value. Okay, because when you sine inverse something, you are never sine inversing the angle, right? You are always, this is definitely wrong. Like for example, angle ABC, you are sine inversing a ratio, a number. So it should be K, whereby K is a constant lah. Okay, your principal value, right, is basically the value that the calculator will throw out. Okay, by now, I think most of you have already learned the different quadrants, right? So when you find a certain alpha value, depending on which quadrant it is in, okay, your angles will be different. So this over here, like this principal value over here is telling you that, okay, if your alpha is a certain value, the sine inverse, right, will give you something in this quadrant over here. So the sine inverse will, hold on, give me a moment. Yeah, the sine inverse will give you something that is from -90 to 90 degrees. So what you need to take away here is basically, this is what the calculator will throw out to you, but it might not be the only answer, because you can go into the positive cycle, you can go into the negative cycle, you can go into the different quadrants as well. So the answer thrown out by the calculator will be in this range for sine, will be this range for cosine, will be in this range for tangent. But these are not the only answers. This is just the answer the calculator will give you. Okay, and then just need to take note, when you see a square bracket, this one usually you all won't see it lah. But if you see a square bracket, it means inclusive of the boundaries. Okay, that means it's also equals to, pi over 2. But if you see a curved bracket, it means it's smaller than pi over 2. It's not inclusive of pi over 2. Okay, now let's move on to the next page. This is very, very, very important. Okay, your special angles, you must know the values that come along with it. Because every time when you see a question, later we'll see a few questions like this. When you see a question, leaving your answer in exact, chances are special angles is involved in the question. Special angles, right? Your 3 special angles that you must remember is your 30 degrees, 45 degrees, and 60 degrees. Don't just remember it in degree. Also tell yourself 30 degree is pi over 6. 45 degree is pi over 4. 60 degree is pi over 3. You have to be able to see interchange between degree and radian. So there are 3 ways you can memorize your special angle values. Okay, special angle values means if you suck in your special angle into the trigonometric function, okay, you will get certain values, certain ratios. These ratios are very important. You have to remember them. First way is you memorize it. You just memorize by heart. You tell yourself sine 30 is going to be half. Therefore, cosine 60 is also half. Okay, this one you learn in E-math. Sine theta is equals to cosine 90 degrees minus theta. You have learned this in E-math before. So sine 30 degrees will be equals to cosine 60 degrees. You memorize it. You memorize sine 30 is half. Therefore, cosine 60 is half as well. Then the next thing you memorize is cosine 30 will be 1 over square root, sorry, give me a moment. It's 1 over, Okay, even I also need to go and brush up on my memory skills, but it will be, oh sorry, it's not 1 over, it's square root 3 over 2. So if you memorize cosine 30 is equals to square root 3 over 2, it means sine 60 is also square root 3 over 2. So you just need to memorize this and this, then you can derive the other two. Okay? Then the other thing that you need to memorize is your tangent lah. So your tangent 30 will be equals to 1 over square root 3. Then therefore your tangent 60, this one you got no choice, you just have to memorize it, will be the reciprocal of tangent 30. And then, okay, we have already satisfied the angle 30 and 60. So the other things you need to memorize is your 45 degrees. So you need to memorize sine 45, cosine 45, tangent 45. Tangent 45 is very simple. You tell yourself is 1. Then sine 45, okay, is actually 1 over square root 2. These are the same thing. These are the same thing. It's just that one of them, this one, is the rationalized version, but they are the same thing. So this is the memorization way to help you remember this table. It's quite, honestly, it might take some time for you to memorize, but this is very important. So you better get it now than you get it later. The next way you can do is the deriving method. So the deriving method means you only memorize one thing and you derive the rest. For example, sine 30 degrees is very easy. Okay, sine 30 degrees is very easy to memorize. We all know it's half by now. And you can derive the rest, okay, except the 45 degree. You can derive all this just by knowing that sine 30 is 30 degrees. Sine 30 is half. How come? If this is 30 degrees, can you see that this is 60 degrees? Okay, it's a right angle triangle. And if this is 30 degrees, it means that, and sine is half, the hypotenuse is 2. The opposite is 1. So by using Pythagoras theorem, you know that this thing will be square root 3. Therefore, you can derive everything. You can derive sine 30, cosine 30, tangent 30. You can also derive cosine 60, sine 60, tangent 60 accordingly. This is the deriving method. Then for your 45 degree triangle, okay, you know that. You just remember tangent is 1. So it's 1, 1 like that. So this one is square root 2. Therefore, you can also get every single special angle value just by remembering two things, sine 30 and tangent 45. Can see that? Okay, so this is a very good way to help you derive every single value if you cannot memorize. The last way is the cheat method, which is the use the calculator method. A lot of students, you're very lazy, okay? Y'all will just use method number 3. But please, okay, at least know that method number 2 exists, because method number 2, you can apply it to, not just like, angle 60 and 30, so, or 45. So knowing how to derive like the different sides just by having one angle, this idea is very useful. So the last method, using your calculator. Okay, feel free to take out a calculator to try this. If you key in, for example, tangent, take that back, sine 45, your calculator will give you a very ugly number, right? So you cannot realize that, what is the exact value? You get a list of decimal. So using the calculator, instead of keying sine 45, you should key in sine 45 square. Okay, when you key in sine 45 square, your calculator will give you a half. So what does it mean? It means that you can work backwards, and sine 45 is therefore square root of half, and it equals to 1 over square root 2. Can see that? Okay, so this is the calculator method. Make sure you know at least one of the methods. I know a lot of students, they hear method number 3, they will just use method number 3. But method number 2 is really useful. So please make sure you know that at least it exists. Okay, so same thing. If you don't know what is the value of sine 60, right, you cannot remember for your life. Okay, cannot remember. So you key in sine 60 into the calculator. The calculator will give you 3 over 4. So it means sine 60 is square root 3 over 2. You just need to square root it in your head. Okay, so this is your special angles. This is very, very important. Emphasizing very, very important. Make sure you know it. Okay, yes, thank you those who are sending the links into the Zoom chat, for those who are just attended. Okay, so yeah, memorization technique, you can also use this but I already taught you guys a different method. Okay, your quadrants. So your quadrants, right, you need to know that there are 4 quadrants, first of all. your first quadrant is always on your positive x-axis and positive y-axis, and it moves in a anti-clockwise direction. And you need to know this acronym ASTC. Okay, some schools I know you all use different ways to memorize, but my method of memorizing is add sugar to coffee. So ASTC, add sugar to coffee. Why do you need to know this? It means that in the first quadrant, all your trigo ratios are positive. In your second quadrant, only your sine ratios are positive. Your third quadrant, only your tangent ratios are positive. Your fourth quadrant, only your cosine ratios are positive. Take note, I'm saying ratio. I'm not saying angle. In the first quadrant, you have a positive angle. In the second quadrant, your angle is positive as well, okay? All the angles are positive. What is positive and negative here is the ratio. So it's the sine of the angle itself, the cosine of the angle itself, the tangent of the angle itself. Please make sure you don't have that misconception. Okay, the angles is not positive or negative. It is the ratio that is positive or negative. Okay, so all this is already covered if you know what is the meaning of ASTC. So, okay, so what's going on in this page? I'm sure most of you have already learned this in school. Okay, but what's going on here is basically trying to tell you how to identify the value of the angle. Okay, take note. You don't, okay, read this part first. You are trying to find the value of theta, okay? You're always interested in theta. You are not really interested in alpha. What is alpha and what is theta? Alpha is a basic angle that can be derived from a right angle triangle, okay? This is alpha. You can derive alpha because if you know the different sides, okay, you know A, B, C, you know these three different sides, the value, you can derive alpha. But theta is not a right angle triangle. Theta is an angle in the quadrant. So there's no like right angle involved. You cannot find theta directly. So the goal is you want to find theta by finding alpha. Okay, so theta is what we are interested in, but we cannot get because there's no right angle triangle containing theta. Therefore, we need to identify an alpha, a basic angle, to help us find theta. Okay, and theta, how you find theta, it depends on where theta is, okay, which quadrant it is in. If theta is in quadrant 1, if the angle of interest is in quadrant 1, theta equals to alpha. If the theta is in quadrant 2, and if you are moving in the positive cycle, positive rotation, okay, theta will be equals to pi minus alpha, or 180 degrees minus alpha. If it's in quadrant 3, this whole stretch is theta, okay? It will be theta is equals to pi plus alpha because, you know, 180 degrees plus your alpha over here, which you can find using a right angle triangle. If you are interested in theta in quadrant 4, okay, it's this whole angle over here. So it's like 2 pi, which is 360 degrees, minus away alpha. Okay, because it's this piece preventing theta from completing a whole circle. If you are confused, like, how come first quadrant is second quadrant is pi minus alpha, third quadrant is pi plus alpha? How to memorize this? Why is it so confusing? Tell yourself, alpha is always glued to the x-axis, okay? It is stuck to the x-axis. So this is the x-axis, okay? This is a way to memorize. Your teacher might not cover in school. So this is your x-axis. You just need to tell yourself, the alpha, the basic angle, is always glued to the x-axis. So if we are looking at theta at the second quadrant and alpha is glued to the x-axis, it means that it is pi minus away the angle being glued to the x-axis. If you are looking at the third quadrant, okay, and you know, theta is in the third quadrant, how to even get until this little bit over here, how to stretch all the way here? You tell yourself, alpha is always glued to the x-axis. Therefore, it must be 180 degrees plus alpha. Same thing in the fourth quadrant, alpha is always glued to the x-axis. So how can theta reach this angle over here? I mean, how can it be this entire thing? It must be 2 pi minus away alpha. Okay, because a lot of times, right, what happens is students get confused. They see third quadrant, right? For example, in the third quadrant, then they forget that A is actually 180 plus alpha. They go and take 270 degree minus alpha, that kind of thing. No such thing. You always tell yourself alpha is glued to the x-axis. So no matter what, you're always looking at either 180 degrees minus alpha plus alpha, or 360 degrees minus away alpha. Because why? Alpha, which is your basic angle, is always stuck to your x-axis. Okay, when I say alpha, right, take note, I'm talking about basic angle over here. Your schools might not use the term alpha, your school might use the term basic angle. So take note, they are the same thing. Okay, then in the negative rotation, okay, it is no longer moving this way. You can move in the negative direction. What does moving in the negative direction means? It means that, okay, instead of going into the first quadrant, you are going into the fourth quadrant first. So if you are going into the fourth quadrant, your theta will be negative alpha. Okay, same logic, because why? Alpha is glued to the x-axis. For there to be an angle formed like that, and you're going this direction, it will just be negative alpha. Then now in your negative cycle, okay, when you're moving is from fourth quadrant then to third quadrant. How to form this angle over here? It's like minus 180 degrees plus alpha, because you are going here, but it actually haven't reached here yet. I only go halfway. So it's like minus pi, but you add alpha back because you haven't went to such a negative angle. Then the next one you go into is your second quadrant. So it's actually minus pi and then minus alpha, because you need to stretch more. It's more negative than 180 degrees. Then when you go to your first quadrant, which is technically the fourth quadrant that the angle hits, okay, you haven't completed the full cycle. So it's not negative 2 pi, it is negative 2 pi plus alpha, because it hasn't completed a full negative circle yet. That's how you understand, and therefore you can immediately memorize this. Okay, you're technically not memorizing, but you're understanding what's going on to help you identify the angle and the formulas. Okay. Now let's go to the next page, your trigonometric graphs. Your trigonometric graphs, honestly, right, this one is you just have to remember. And it's very important for you to remember your trigonometric graph shape, because if you don't remember and the question asks you to sketch, there's no way you can like draw a graph out of nowhere. So you need to know the general shapes of your trigonometric graph. And remember, just now we have our special angles. Okay, we have our special angles. I didn't go through how to memorize this. Okay, I didn't go through how to memorize this. Why? Because you can derive them in your trigo graph. Okay, so you don't even have to memorize a special, okay, 0 and 90, technically they are special angles, but you don't have to memorize them. You just need to look at the trigo graph. Okay, I'll come back to this page, but let me go through what I mean by that first. Okay, most of you by now, you guys should know that this is how a sine graph looks like. The sine graph has a maximum point of 1, a minimum point of -1, and the period is the very basic sine graph, means there's no fancy numbers here and there. Okay, the basic one. This is a basic sine graph. You will know that the period is 360 degrees. If you know that this is the general graph shape, immediately, right, when I tell you, okay, find the value of sine 0, you should be able to tell me it's going to be 0. Why? Because the graph already tells you is 0. If I ask you for sine 90, you should also immediately tell me it's going to be 1. Because why? The graph shape already tells you that it's going to be 1. Same thing, if I ask for sine 180, you should know that it's 0. If I ask for sine 360, you should also know that it's 0. If I ask for sine 270, it will be -1. How do you know all this? Because you already know the graph shape. Don't waste your time to use your calculator, click, 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 what is sine 90, what is sine 180. You don't have to, because you can derive all this from the trigo graph itself. Okay, the same idea holds for a cosine graph. You guys should already know by now, the maximum is at 1, the minimum point is at -1, and this is the general shape. The period is 360 degrees or 2 pi. So same thing, immediately, if I ask you, what is the value of cosine 90? You should tell me 0. Why? Because you already know the graph shape. The graph cuts the 90-degree point at y equals to 0. Okay, so don't go and waste your time clicking on your calculator. But if you super kiasu, you want to track your work, go ahead. Okay, so coming back to this page, this is basically explaining what is the meaning of A, B, and C. Okay, A is your amplitude. Amplitude means how high or how far the graph stretches up or squeezes down. So the bigger the amplitude, it means that your graph will be stretched further. Okay, and if your amplitude is a negative value, for example, if A is equals to -2, your graph will flip about your equilibrium line. Equilibrium is this thing over here. Later, I will go through more about it. But if there is a negative sign inside this value, your graph will be flipped. Okay, if you have attended session 1, it's actually something very similar to your logarithm concept. Remember, for those that attended session 1, right, when there is a negative sign in front of the graph, okay, the graph flips about the x-axis and the y-axis. So it's the exact same idea here. Because there is a negative sign affecting the whole graph, there will be a flip in your graph shape. Okay, it will reflect about the equilibrium. Okay, so you can read more about this. What I mentioned is already stated here. And B over here, okay, B is not the period, that's a typo. B affects the period. Your typical sine and cosine graph, you guys should know this. If you don't know this, please memorize this. The period is 360 for your sine and cosine graph. What is a period? A period is the space where your graph completes a full cycle. So if the period is 360 degrees, it means that you see the entire sine graph in 360 degrees. If I tell you, okay, if I mark out here 360 degrees and 0 degrees over here, and I tell you now, this graph has a period of 180 degrees. It means if the question asks you to draw from 0 to 360, and if the period now is 180, I will see the completed graph twice. Okay, so the period is the x value where your graph completes one cycle. How do you find the period? Okay, this is the formula in your notes, but I like to use this formula instead. Okay, because usually the question will not ask you what is the value of B, but rather they will ask you what is the period of this graph. So I want to make period the subject. Okay, so for a cosine and sine only, this is the formula. It will be 2 pi divided by the value of B, and B is found over here. Don't worry, B will not be a negative number. It will be a positive number. Okay, so this is how you find your period. Use this formula. If you ever get confused, just remember period equals to 2 pi over B. Then if the question asks you what is the period, you just plug in the value of B and you will get the period of the graph. Okay, technically B over here, right? B over here, okay, if you guys want to know this, is the number of times the graph appears in 360 degrees. So if my B is equals to a 2, can you see that my period is actually equals to 180 degrees just by using the formula that we have just went through? So what does it mean? It means that in 360 degrees, from 0 to 360 degrees, the graph will complete twice because B is equals to 2. So there's 2 ways you can go about it. You can tell yourself B is how many times the graph completes in 360 degrees, or you can tell yourself, okay, if B is equals to 2, then I find the period first. Then after I find the period, I draw the graph. Then I realize, it appears twice. Okay, you can use these 2 logic to help you check your work as well. Okay, and C over here is called the vertical translation. We're moving to C already. Okay, is how much the graph moves up or down. It's different from A. A is how much is being stretched. C is where you position the graph. Okay, and the value of C is important because it determines where your graph starts. What do I mean by that? If your graph is Y, equals to sine x plus 2, okay, your graph is no longer like this, okay? It no longer sits on the x-axis. It starts at this line, which is y equals to 2. So because your graph starts at a different point, can you see that it will also affect your maximum and minimum point? Okay, it's really important. So make sure you know where the graph is first. Okay, you know the C value first. You put it in your graph. I mean, you draw out your graph. Okay, and then you can find the maximum value and the minimum value accordingly. Okay, how do you find the maximum value? Maximum value will be C plus A. Okay, max value of the graph will be C plus A. Minimum value, okay, provided A is a positive number, minimum will be equals to C minus A. Then another question is, if you happen to, the question say the minimum value and the maximum value of the graph, but you don't know the amplitude. How to find the amplitude? You just take the maximum value of the graph minus the minimum value, divide by 2. Okay, because if this is the maximum and this is the minimum, you minus them, you get this entire distance, right? Then if you divide by 2, you will get the equilibrium line. Sorry, you will not get the equilibrium line, say wrongly. You will get the amplitude, because the amplitude is the distance away from the equilibrium line. So tell yourself, if you know the maximum value of the graph, you know the minimum value of the graph, how to find the amplitude? You take max minus minimum divided by 2. Then after you get the maximum, after you get the amplitude, you can take the maximum point minus away the amplitude to find the equilibrium. Okay, later we'll go through some questions that involve these concepts. Okay, so yeah, we went through this just now. So please make sure you know it. For sine and cosine, really important. Okay, so when the period changes, the position of the maximum and minimum point will also change as well. So don't always assume for a sine graph, sine 90 is where the maximum point is at. I mean, yes, but if there is a graph like that, okay, if this is your equation of your trigo graph, okay, x equals to 90 will not be where the maximum point is at already. Be very careful. So as your, why is that so? Because your period has already changed. When your period changes, your maximum point will also like follow accordingly. So what I like to do is, I like to divide the graph, okay, in one period into 4 pieces. Okay, what do I mean by that? This is a graph in this is your graph in one single period, right? I like to divide it into 4 pieces. Piece number 1, piece number 2, piece number 3, and piece number 4. So you tell yourself, at the first quarter of the sine graph, if the amplitude is not negative, that means when the graph is not flipped, you will find your maximum point. At the last quarter, you will find your minimum point. Then that's where, right, even no matter how different the period is, I will be able to pinpoint exactly where is the maximum point, where is the minimum point, because I cut the graph into 4. Okay, the maximum will be found in the first quarter, the minimum will be found in the second quarter. If the sine graph is flipped instead, okay, when your amplitude is negative, okay, same thing, I cut the graph into 4. So now my minimum point will be in the first quarter, my maximum point will be in the last quarter. Why do you need to know this? It's so that if you come across a sketching question, you know where to mark out your points. Okay. So cosine graph, same thing as well. I like to cut it into 4 pieces. Right smack in the middle is where you will find your minimum point. Then at the starting and at the ending, you will find your maximum points. At the first quarter, you will find the point at the equilibrium. At the last quarter, you will also find the point at the equilibrium. You plot all this out, then you can connect them, and then you can sketch your cosine graph. Okay. Moving on to the tangent graph over here. Tangent graph is honestly it will be tested, but it will be is more likely to appear less. Okay, the period for a tangent graph is something that you need to take note of, most importantly, because it's different from your sine and cosine graph. Your period for tangent graph is 180 degrees. So it means that the graph repeats itself every 180 degrees. Can you see there's a repetition at this point already? This is exactly the same as this. Okay, and how do you draw the tangent graph? You just tell yourself is 0 tending towards infinity, and then from infinity tend back to 0. Where does this thing appear? Okay, where does the asymptote appear? It will be in the middle of the period. So similarly, just now we cut the graph into 4 pieces, right? For a sine graph, you should cut it into 2. If you know that, for example, the period of this, tangent, I meant to say tangent graph. For example, if you know that the period for this particular tangent graph, instead of the normal, 180, I put a 2 here. Okay, if I put a 2 here, it means that the period is actually 90 degrees. Can see that? So if it's a 90 degrees over here, where do I draw the asymptote? I cut the graph into 2. So the asymptote is actually at x equals to 45 degrees. The same concept holds from 0, 10 to the asymptote. From the asymptote 10 to 0. Okay, move to 0. So this is how you would draw the graph. Okay, there are questions that will only require you to draw part of the trigo graph. So don't be alarmed. What do I mean by that? Okay, if this is the question, right? I ask you to sketch this. Clearly that it's very clear that the period is 360. Right? Okay, but instead of asking you to draw until 360, the question can say, oh, draw until this point only. Okay, so if the question asks you to draw until this point, it means that it's actually not asking you to draw the complete trigo curve. It's actually just asking you to draw this. It could happen, okay? So don't be alarmed. The question can also ask you to draw this. Okay, so what does it mean? It means you stop here. You don't go back up. So this could happen. There's nothing wrong with that. Just make sure you are answering the question accordingly. Common mistake. So make sure you are answering the question accordingly. Don't go and draw too little. Don't go and draw too much. Because if you overdraw, you will get penalized as well. Okay. So now let's move on to trigonometric identities. Okay, let me drink some water. For trigonometric identities, right? Some of you might realize that these are very familiar. Why? Because you have already learned them in E-math, some of them. Complementary angle identities and supplementary angle identities, you have learned it in E-math. Oh, and there's a typo over here. The third one is not supplementary, it's reflect angle identities, and supplementary angle identities is missing in the notes. Okay, for reflex angle identity, supplementary angle identity, and negative angle identity, right? You can actually derive them. If you cannot memorize them, okay, it's not too bad because you can derive them. How do you derive them? Okay, in school, your teacher probably did not teach you how to derive them. In school, you are just given this and then you're expected to memorize it. Okay, if you don't know how to derive, you need to memorize. Or if you don't want to learn how to derive, you need to memorize it. Okay, because why? A question can give you sine A, the value of sine A. Then they ask you for the value of cosine 90 degrees minus A. If you don't know this formula exists, you will never be able to derive this if you are given this. Okay, so all these identities here are very important. This one, complementary angle identities, you just have to memorize. Okay, you should already know by now because you have learned this in E-math before. But for the three negative angle identities, reflect angle identities, and supplementary angle identities, you can derive them. How do you derive them? You just need to know your quadrants. Okay, remember, imagine, just let A be an acute angle. We let A be an acute angle. If A is acute, can you see A is in the fourth quadrant? In the fourth quadrant, is sine negative? It is, right? In the fourth quadrant, sine is negative, right? Because ASTC, fourth quadrant, only cosine is positive. That's why if you remove the negative in the angle, okay, we are looking at a first quadrant angle. Can you see that? And then this will definitely be positive. If this is negative and this is positive, how can they be equal? Therefore, you need to put a negative sign in front to make sure that they are all, both of them, your left-hand side is equal to the right-hand side. Okay, this is how you can derive them. For example, cosine negative A. Negative A is in the fourth quadrant because we let A be acute. This is a fourth quadrant. is in the fourth quadrant. Therefore, this value will be positive because cosine an angle in a fourth quadrant gives you a positive value. So same thing. If this is the acute angle in the first quadrant, is it already positive? It is. Therefore, you don't need to put a negative sign in front. Can see that? This is how you derive the formulas. Same thing. You ask yourself for tangent in the fourth quadrant, this whole thing will be negative, right? If this whole thing is negative, tangent A, acute angle, this is in the first quadrant. Is it positive? It is. So how can a positive number be equal to a negative number? Cannot, right? So you must put a negative sign in front. Therefore, your negative angle identities, if you know how to derive it, right, you never need to go and memorize it already. In school, your teacher will probably just tell you cosine is the special one. Remove, don't have the negative sign. But for sine and tangent, there will be a negative sign in front. Also can, but if you ever forget, tell yourself you can always derive it using the quadrants. Okay, for your reflect angles identity, same thing. You ask yourself, you let A be an acute angle, okay? We just let A be acute. Even if A is not acute, it can also be explained using the same concept. You can think of it on your own, but we don't have time to go through that today. But you just tell yourself, let A be acute to explain the scenario. If A is acute, can you see that this whole thing is in the fourth quadrant? Okay, same thing. This whole thing will be negative because fourth quadrant angle put inside a sine function, this whole value will be negative. This is acute, right, in the first quadrant. So therefore, positive cannot be negative. You need to put a negative sign in front. It's the exact same thing. Then for the cosine one, you will expect there not to be a negative sign because this is positive in the fourth quadrant and this is also positive. Therefore, that's it. You don't need to put a negative sign in front. Don't need. Then tangent one, by now you should already realize, if you understand what I'm trying to explain, there will be a negative sign in front. Okay, and then for your supplementary angle identities, exactly the same concept. This thing over here, we let A be acute. So this angle, it will be in the second quadrant. Second quadrant, sine is positive. Therefore, there is no negative sign in front over here. Second quadrant, cosine will be negative. Therefore, you must put a negative sign in front because this will be positive. Okay, and then tangent, exact same idea. This whole thing will be negative. This is positive. Therefore, you need to put a negative plus minus sign in front. Okay. Which quadrant is the negative angles? Okay, someone asked. Okay, when you type out this question, right, I can tell you that you have some concept error already. Okay, quadrant doesn't give you a negative angle. Negative angle is when you are moving in the negative rotation. If you are moving this way, can you see theta is equals to negative alpha? Theta here is a negative angle. Okay, if you move in the negative cycle, you will get negative angles. But if you are talking about quadrants, remember just now when we were doing the ASTC, okay, I mentioned here that these ASTC are ratios, they are not angles. Okay, in the first quadrant, let's for example, in the second quadrant, theta is going to be a positive angle. Sine theta will be positive. Cosine theta is negative. Theta is not negative, but cosine theta is negative. There is a difference, and this is a very common mistake. That's why just now I already emphasized, okay? Make sure you know that ASTC is talking about ratio. Then same thing, tangent theta is also equals to negative because it's in the second quadrant. Okay, theta is positive, but it is the ratio that is negative. It's good that you clarify it now before you make this common mistake again. Okay, so if you don't understand what is going on, use your calculator to help you give you an example. Key into your calculator right now. Any angle in the second quadrant, for example, an angle in the second quadrant will be, 135 degrees. It's in the second quadrant because it's smaller than 180 degrees, but bigger than 90 degrees. You key in sine 135, make sure you're in degree mode, you will get a positive output. You key in cosine 135, you will get a negative output. You key in tangent 135, you will get a negative output. Can see that? Okay, why is that so? Because it's explained with the quadrants. The ratio changes sign, but your angle is still the same, 135, it is a positive angle. Okay? If anyone has any questions, feel free to let me know, type it in the chat box. Okay, it's good to ask questions because someone might have the same misconception as you. Okay, so you guys shouldn't have any excuse not to remember this. I'm telling you, this is very important. This is as important as the special angle page. Okay, if anything you need to memorize, these are the two things you need to memorize first. Now, let's go to quotient identity. Quotient identity is straightforward lah. You just tell yourself tangent A is equivalent to sine A over cosine A. If you don't want to know why, okay, if you want to know why, it's because sine A is opposite over hypotenuse. Do you remember? Cosine A is, okay, because divide, why I write divide? Because there's a divide here, is adjacent over hypotenuse. If you see a divide, you learned this before, right? In Sec 2 or Sec 1, it will become a multiply, the reciprocal, right? Then it cancels out. Then it becomes tangent theta. So this explains why sine A over cosine A is equivalent to tangent A. This is the explanation. Okay, you don't need to know the explanation, but it's good to know lah, so you know what you're doing. Then cotangent A is equals to cosine A over sine A. It's just a flip because cotangent A is a flip of tangent A ma. Okay, and your reciprocal identities, we have already went through this at the beginning of the notes. Okay, let's move on to the Pythagorean identities. This one is provided in your formula page. Okay, it's provided. You don't have to memorize the formula word for word. You don't have to because they are provided, but very important, you need to know what exists. What do I mean by you need to know what exists? It means that if you ever see a sine square A, okay, in your question, you need to know that there are formulas that you have learned that involve sine square A. So you need to realize that there is this formula that I've learned to help me deal with sine square A. Okay, you don't have to memorize, oh, sine square A plus cosine square A equals to 1. But you need to know that if I see a sine square A in the question, I have to remember that there is a formula like this that exists to help me change my sine square A to something else. Okay, it's very, very important for you to be familiarized with the formula. Because why? I'm sure you guys have also came across proving questions, okay? You need to prove the left-hand side equals to the right-hand side, that kind of trigo, question. For example, hold on, let me pull out an example question. Something like this, okay? 2a part 1. You need to prove that this equals to this. For this kind of question, if you don't know that that formula exists, right, you might not know how to deal with this sine square X. So you need to know what formulas exist at the back of your head, okay, for you to come up with an idea to deal with the question, or else you will feel very stuck when you see a proving question. The main idea is, okay, you need to know what formulas exist. You might not need to know exactly how the formula looks like, but you must know that, oh, there's a formula that exists that can link my sine square A to my cosine square A. So if you ever see a sine square A, immediately you should tell yourself, I can always convert this to cosine square A because I know this formula. Okay, so there are 3 Pythagorean identities over here. There's your first one, second one, third one is all shown here, right? Okay, so same thing. When you see there's a second one, right? When you see a secant square A, immediately you should tell yourself, okay, there is an identity that can convert my secant square A into a tangent square A. Okay, then same thing, the third one. If you see a cotangent square in your question somehow, immediately you must tell yourself, I know that there is a formula that can help me transform this into a cosecant square A. So you must know what formula exists what it can be changed into. The exact details of the formula is not as important as knowing that what exists and what it can change into. What do I mean by it can change into? For example, if I give you a question like this, cosine square A plus 2 sine A equals to 1. This question, I ask you to find the value of A. How would you do it? You're supposed to find the angle. There is no way to do this question just like that, because cosine square A and sine A is two different trigo terms. But what do you need to do? You need to realize that your cosine square A can be converted to a sine square A. Why is that so? Because of this formula. So cosine square A is actually equals to 1 minus sine square A plus 2 sine A equals to 1. Can see that? So this is how you will approach the question. How do you even start off with this question is to recognize that, hey, I cannot move forward over here, but I do know of a formula that can transform cosine square A into sine square A. That's why I should apply the formula and continue with the question. And then this makes it very simple already. It will simplify to sine square A minus 2 sine A equals to 0. Sine A, take out common factor, sine A minus 2 equals to 0. Okay, sine A equals to 0 or sine A equals to 2. Okay, I want you guys to think, how would you continue from here? Don't need to answer me, but ask yourself, how would you continue from here? Okay, sine A equals to 0. What did we just learn? We learned that if it's equals to 0, you can just use the graph. Okay, so I forgot to put in a boundary here. I have to give you a boundary so that you don't have too many answers. So my boundary will be 360 degrees, 0 degrees. So A will be equals to 0, 180 degrees, 360 degrees. Then this one over here, there is actually no solution. Because your sine A graph, does it ever go past the 1 mark? It doesn't. The maximum value is 1. So this thing does not exist. There is no solution. Okay, so please make sure you know your Pythagorean identities well. You don't need to know it word for word, but you need to know the relationship very well. Okay, let's move on to the proof you read on your own. Not very important, to be honest, but it's good to know. Oh, sorry, forgot to mention one more thing. Your 3 Pythagorean identities are same thing. Okay, it's given in your formula sheet, so don't need to worry. But they are actually all the same thing. They are related. How do you get from here to here? You just see that it's actually divide both the left-hand side and right-hand side by cosine A. Okay, because 1 divided by cosine A gives you, sorry, right wrongly, it's not cosine A, it's cosine square A. 1 divided by cosine square A gives you secant square A. And then sine square A divided by cosine square A gives you tangent square A. Cosine square A divided by cosine square A gives you 1. So actually they are the same thing. You just need to divide throughout by cosine square A to get from the first one to the second one. The third one is actually also the exact same idea, but instead of dividing throughout by cosine square A, you are dividing throughout by sine square A. Okay, you see, like there are so many things that actually can be derived. Okay, so what does it mean? It means that there's a lot of ways for you to do a single question, because you can always use this formula or this formula or this formula because they're actually the same thing. So what does it mean? It means that you can check your work, because if there is more than one way to do a question, it means that you can use 2 different ways and get the same answer. And if you have 2 different ways and you get the same answer, it means that your answer is definitely correct. Okay, make sure, as good practice, if you have the time, when you're doing a trigo question in school, if you realize there's more than one method, go ahead and use both methods. Why? First reason is as practice. Okay, the more you practice the different methods, the better you'll get. The second reason is you can check your work. If the 2 methods give you the same answer, you will be able to be very sure that your answer is correct. Okay, then there is your addition formula. Same thing is provided in the formula sheet. You don't have to really remember word for word. It's good to remember word for word lah, okay, but it's not a need. But what you need to do is every time you see this, you must tell yourself you can convert it to this. Every time you see this, you can tell yourself you can convert it to this. That is the most important thing. Recognize what you can convert something into, okay, using the addition formula. Double angle formula, okay, this is a common mistake that students have. When they see double angle formula, they think that inside the formula, it must be a 2. It must be a 2a, a 2 theta, a 2, a b, whatever. They think that there must be a 2. No, okay. Double angle formula, so long as there is a doubling or halving situation relationship going on, okay, you can use your double angle formula already. What do I mean by that? If I give you sine 3a over 2, okay, and I give you sine 3a, you can use double angle formula to actually connect these two, okay? So sine 3a is actually equals to sine 3a over 2, put a 2 in front, I forgot to put a 2 in front, and cosine 3a over 2. This is also a double angle formula, okay? Why is it a double angle formula? Because this is double of this. Can you see that? Okay, double angle formula doesn't mean the coefficient must always be a 2 and a 1 here. No, it means that the coefficient here just needs to be times 2 of the coefficient here. If the coefficient here is a 5, then here is a 10. If the coefficient here is a 4, then here is a 8. It is still your double angle formula. Okay, so make sure you know this. Okay. So when do you use double angle formula? Same thing. If the question, you see something like sine A, then suddenly you see 2A in the question, immediately you should tell yourself, this question confirm need to bring in double angle formula. Or if the question you suddenly see 5A, then after that you see 10A, same thing. Immediately you bring in double angle formula because it has to be involved somehow. Okay, for cosine double angle formula is actually the trickier one. Why is it trickier? Because there's 3 of them. Okay, so if there's 3 of them, right, it's very question dependent. It depends on how the question is, then you identify which one you need to use. For example, just now that question, remember, we are solving for the angle A. Okay, we're solving for angle A, right? We definitely want all this to become a sine, right? We don't want cosine to appear. So if a question like this happens, a similar question appears, and there is a cosine 2a instead, naturally you will pivot towards this formula because you don't want any cosines involved in your calculation. So this is how you identify which formula out of these 3 you should be using. You need to look at the question first, then you ask yourself which one will make the question easier. Okay, then tangent double angle formula, yeah, it's just here. Your double angle formula is actually the same as your addition formula. Okay, why is it the same? It's basically the same angle added together. So you can actually derive your double angle formula from your addition formula. Can see that? Okay, you don't need to derive them, okay, because this is provided in your notes already, in your formula sheet already. Now, there is your half angle formula over here. This one is not taught in school, okay? You don't need to know this because you can derive this. How to derive this? Your double angle formula, okay, how you derive this is actually using your cosine 2a double angle formula. How to derive is your double angle formula. You notice that the subject is the angle that is doubled. Can you see that? Okay, what do I mean by subject is the angle that's doubled? This is the subject. It contains the doubled angle. It is in terms of the single angle. Can you see that? So if I want to make the single angle the subject, I would just, okay, for example, I will focus on this one. Okay, if I want to make this the subject instead, why do I want to make this the subject? Because the question can say cosine 2a equals to maybe 1/7, okay? And then I ask you, find the value of cosine a, Okay, find the value of this. How would you do that? The fact that they give you 2a, you want a, immediately you bring in your double angle formula. But you want this, therefore you want to make this the subject. How do you make this the subject? You use your double angle formula and you rearrange it. So can you see if I minus 1 on both, I plus 1 on both sides, I divide by 2, I square root it, but I must put a plus minus because I'm square rooting a square term. So there must be a plus minus in front. I will get a cosine A. Can see that? If I want the value of cosine A, but I have only the value of cosine 2A, can I already get it now? I can, because I just need to sub it inside here. This is why you need to know half angle formula. It's because they give you the double angle value, you are expected to find the single angle value. But you don't have to memorize this. Why is that so? Because you can derive it. The cosine 1 and sine 1 is derived using this formula and this formula respectively. The tangent one is just sine A over cosine A. Can see that? Okay, so yeah, make sure you know how to derive your half angle formula. It's important because there are questions that come out, these kind of questions that come out quite often. Okay, now let's move on to your R formula. Your R formula, honestly, you just need to memorize the formula. This one I cannot help you, you just have to memorize it. Okay, you need to memorize how to get the value of R and how to get the value of alpha. Your alpha is a common mistake. Why? It's always the behind coefficient over the in front coefficient tangent inverse. Some students, they like to flip this, they put B over A instead. Okay, no, it's A over B, just take note. And the thing that you put inside here will always be a positive number. A and B are always positive. The plus, this is a common mistake. A and B that you put inside your tangent inverse, they are positive. The plus minus here, don't go and group it with the A. No, okay? The plus minus here affects the plus minus inside your R formula, inside the cosine function for this particular cosine form R formula. Okay? R formula got two types. There's your cosine form and your sine form. Don't have tangent form. Okay, if you want a cosine form, please make sure you put the cosine term at the front. If you want your sine form, okay, please make sure you put the sine at the front. Okay, what if the question, okay, this is a common question as well, and some students are not able to deal with it. What if I give you a question like that? Negative cosine, sine A, okay, 3 sine A minus cosine A equals to maybe half, okay? But I want you to convert this into a cosine R formula. How would you do it? Okay, I don't want sine R formula, I want cosine R formula. The first thing you should do is you tell yourself, okay, those that know how to do it, great, okay? But for those of you who are unsure, please make sure you know how to deal with this. If you want a cosine R formula, is it right to say that this needs to be in the front? It is, right? So you push it to the front first. Don't worry, bring the negative sign in front as well. And then you will get this. Okay, but your R formula, your B must be positive, right? Okay, your B must be positive. So what do? You take out the negative as a common factor. So this happens. Oh, sorry, it should be a half here. If I make any mistakes, just let me know. I'm also human, I'll make mistakes one. Okay, can you see that? Then after that, when you want to deal with your R formula, you work with inside the bracket instead. So actually at the end of the day, you will get something like this. Negative R cosine A plus alpha equals to half. Can see that? You will simply just have a negative sign in front, and that is totally perfectly fine because it's still a R formula. Okay, so what am I trying to say here is don't be alarmed if your R has a negative sign in front. It is perfectly fine. It's just that your graph is technically flipped. Okay, remember just now when your amplitude, there is a negative sign, it will flip, something like that. The maximum will still be the same value. The minimum will still be the same value. It's just in a different location now because the graph is flipped. Okay, so your R formula coming, okay, what I was mentioning just now is this thing lah, okay? So this is another example. Okay, just make sure you understand what is going on over here. Take some time to look at it. Okay. Your R formula questions, usually, I think you all know by now, you will see this kind of funky looking figures like, oh, got a lot of like triangles involved. Then they ask you to, prove that a length is equals to this particular trigo expression. Okay, so a R formula question, usually this portion is not given. You need to, they give you a context, okay? You need to form this part on your own. The question will be part A, prove that this happens, okay? This is the typical type of question. So you need to know and how to form this part on your own. The trick to form this part, right, is to always force out right angle triangles containing theta as an angle in your figure. Okay, so if you have a very fancy looking diagram, fancy looking figure, you just force yourself to try and come up with as many right angle triangles you need that contains the angle of interest. Okay, in this case, it will be A. Once you start forcing this kind of triangles out in your figure, right, you will be able to prove this eventually. Why do you need to force out right angle triangles? Because only right angle triangles can give you tuakaso, sine and cosine involved, okay, included. Okay, so the proof of the sine form, all these, you can go and read it on your own lah, not very important. Honestly, this one also not very important lah, okay. This part is the important one, this one. This one at the back is basically just telling you that, oh, you can actually apply your addition formula in as well. Okay, you might need to use it at times, but it's not the key thing here. Okay. So now let's come to 1.4 trigonometric equation. This one is basically just trying to show you examples of questions whereby you're solving for the angle itself. Okay. When you are doing this kind of solving for angle question, the most important thing, okay, the first step is to make sure that you are in the right quadrant. Okay, because if you are not in the correct quadrant, your answer will be wrong. Okay, and you also need to make sure that the range you're looking at is correct. Okay, what do I mean by range? For example, this question, they ask you to find all angles between 0 and 2 pi. Okay, the word between is very subjective. Depends on what your school teachers say. Okay, please go and ask your school teacher what does between means, because in the past, between means exclusive. But then suddenly, one fine day, suddenly we start seeing inclusive. Okay, what do I mean by exclusive, inclusive? Means this thing. Okay, by default, between means exclusive, but there are schools that treat between as inclusive. Inclusive means got the equal sign. So go and ask your school teacher what which one they are actually referring to, but usually is this one lah. But nowadays, they are more kind. They say find all the angles between 0 and 2 pi inclusive, or they will explicitly say find all the angles between 0 and 2 pi exclusive. But it's important because, for example, like just now we have this, right? And we solve that x equals to 0, 180 degrees, and 360 degrees. If it's exclusive, these two answers, we need to exclude them. So this is very important. Make sure you answer the question accordingly. Okay, so you need to make sure you're in the right range and in the right quadrant. So how do you do this question? We have already did this just now, something similar. You realize that sine and cosine, you don't want to deal with two different trigonometric functions. What you will do is you will convert either the sine to become a cosine or the cosine to be a sine. But are you able to convert this to a cosine? Have you learned any identities that can help you convert it? No, right? The only identities you have learned is your Pythagorean identity, your double angle formula, addition formula. You cannot convert this into a cosine. But can you convert this to a sine square? You can. Therefore, that is your only way. You convert it to a sine square first, and you will get something like this, okay? You get something like this, and you will get something like this, okay? And you reject this. Technically, it's not rejected, it's no solution, okay? No solution because the solution doesn't exist. Rejected usually means there is a solution. But for example, for example, we are talking about height over here. If your height is -2, it is rejected. But this one it doesn't even exist. So technically it's no solution. But at your level, if you write reject as no solution, is fine as well. Okay, for secondary school standards. Over here, okay, the first thing you need to do is, okay, your range, you need to make sure you're in the right range. So please make sure all your answers that you find later are in this range. Then now you ask yourself, sine 1/5, is it positive or is it negative? Okay, it's positive, right? So what does it mean? It means that your theta is in the first or second quadrant. When you're finding for theta, remember just now what we mentioned? We cannot find for theta directly. We need to find for alpha, then we can find for theta. So over here, we are solving for alpha first. Alpha will be equals to sine inverse 1/5. If this is a negative, if there is a negative sign in front, your alpha is still sine inverse 1/5. Do not put a negative inside your sine inverse when solving for alpha. Inside your this step over here, this number inside is always positive. The plus minus sign over here affects the quadrant. It doesn't affect your alpha. Because this question, there is no negative sign, it means that there is a positive sign lah. So it is in your first and second quadrant. So your theta is actually equals to alpha or pi minus alpha. Can see that? Because it's in your first quadrant, it's in your second quadrant. Okay? So the next thing is to ask yourself, does your answer make sense? Because this is the most important thing. Make sure you're in the right range. Make sure you're looking at the correct quadrant. These two answers, does it lie inside the requirement range? It does, because it's confirmed bigger than 0, what? This one. And this one is confirmed smaller than 2 pi. So therefore, these two answers are correct. Then the next thing to ask yourself is, are there more answers? Okay. Are there more answers? The next answer is actually in the first quadrant again, but it is in the second positive rotation. Can you all see that? It goes in another cycle. So the next answer is actually 2 pi plus alpha. But has it already exceeded the boundary? It has. That's why you don't need to include it. Okay? So always make sure, good practice is you write this at the side. Okay, write it at the top right hand side of your workings. Okay, because when you write this down, you are very sure to whether it makes you more like certain that you need to check your answer against this range because it's there already. So you will basically check your answers. You'll be more aware to check your answers. So write this thing, okay? Write this thing. It's very important because there are times whereby you're not solving for x, you are solving for 2x instead. Then your boundary will change accordingly. Okay? So please make sure you write this thing. Then if you need to solve for 2x instead, you write this thing also. So now, okay, we already went through this. Okay, it's in radian mode. Yep. So we found, okay, this is alpha lah, basically. Sorry. Okay, the presentation here is not the best. These two should be put together lah. Okay, you should write them together. You shouldn't separate them. But yeah, the answer will be, okay, it shouldn't be theta here. Sorry, my bad. It should be an x over here because the question is x. So make sure you have all your answers. Make sure you're not giving anything lesser than the two solutions. Make sure you're also not giving anything outside the boundary. Okay. So now, yeah, common mistake. This one very important. Okay, very important. Why is it very important? Because this mistake is like a hot favorite. Okay, y'all like to make this mistake. This mistake is not just in a Trigo chapter. It's in other chapters as well. Every time when students see this, they feel like, oh, I can just cancel out the cosine x. Like it makes it a lot simpler. No, okay? You can never cancel anything that contains your variable. What do I mean by that? If you see a 2ab equals to maybe 4a, okay? You can cancel away the 2 and the 4 to give you a ab equals to 2a. You can do that. Why can you cancel this? Because you're removing a factor of 2. Does 2 contain a variable? No, it doesn't, okay? 2 is just a number. But if you remove the a, you are removing a factor that is a variable. A variable contains a solution. So literally, if you cancel A like that, you're throwing away one of your solution. So same thing. This cosine x contains x, right? If you cancel cosine x on both sides, you are throwing away one perfectly good solution. So please do not do that. Instead, you should treat it as a common factor, take it out, and you will be able to solve it as a factorization question. Can see that? Okay, so yeah, just read this if you need to. Do not throw away your solutions. Okay, and then hold on now, what is this? Oh, this is just a typical substitution question. So this question over here, okay, hold on. Yeah, this question over here, they ask you to find all the angles between 0 and 2 pi. So the first thing you should do is make sure you are looking at the correct boundary. So I will write this first. Okay, then the next thing you do is you want to solve for x. There's something here that appears, right? Like we mentioned just now. You see a 2x, you see a x. What formula should you immediately think of? Yes, very good, double angle. So you should just plug it in, okay? Just put it in and you will get this. Then after this, it's quite straightforward already. Who will want to deal with a denominator with a tangent square? No one, right? So you will multiply throughout by 1 minus tangent square x. Okay, you can do that, or you can do this other method instead. Okay, what I mentioned is correct, nothing wrong with that. But this other method is to help you in a way simplify your working, because some students might not like to deal with tangent square x. Okay, they might want to convert this into a quadratic equation or a cubic equation. So how do you convert this into a quadratic or cubic equation? Is you kind of replace, you substitute every single tangent x with some other dummy variable. When I say dummy variable, it means that it doesn't need to be a y. It can be a k, it can be a u, whatever. If you do a substitution, you will get this at the end of the day. Okay, you will get this at the end of the day, but take note, you are not solving for y, you're solving for tangent. So technically, you need to, there's a missing step over here. This is equivalent to this. Can you see that? Therefore, it is equals to tangent x equals to 0. This is the substitution method to make your life a bit easier. But if you don't want to use substitution method, it's perfectly fine. And this is how it will look like. Okay, I just multiplying throughout by tangent square x. 1 minus tangent square x. And I will get this. Okay, I will get this, right? And then, oops, there's a 0 here. Sorry, there's not enough space. Okay, that's a 0. Let me rewrite that. And then I will get 2 tangent cube x equals to 0. Then isn't it the same thing as tangent cube x equals to 0? Then you cube root both sides, because cube root don't need to put a plus minus. It's the exact same thing. Okay, so it's like a tip lah. If you cannot deal with this kind of complicated looking stuff, you can do a substitution. But if you can deal with it looking more complicated, I mean, if you can deal with it, even though it looks more complicated, go ahead and just stick with it. Okay, don't need to do the substitution. Okay, then when tangent x equals to 0, same thing. Okay, when you have a 0 value, don't use your calculator. Think of the graph shape. Tangent graph, we already know that it will look like that, right? So it means it's going to be 0 degrees, it's going to be 180 degrees. But what did we say just now? Make sure you are answering everything. Okay, so is there another solution? Yes, there is there. Okay, yeah, yes, there is another solution. It will be 360 degrees. Okay, but my bad, I shouldn't be leaving my answers in degrees. I should be leaving my answers and workings in radian, because the question is in radian. So just by using the graph shape, we know that x is going to be equals to 0, pi, and 2 pi. If you didn't write this range out, right, you might have missed out the pi, the 2 pi answer. Okay, yeah. So in a way, the word between here technically is inclusive. Okay, it's inclusive. So this word is really very subjective lah. So please make sure you ask your school teacher, what do they use the word between as? Is it inclusive or exclusive? It differs between schools. Okay, here they treat it as inclusive. Okay. Oh, okay, so for O levels, if the word between comes out, the trend is they are very kind. They will say between and inclusive, or they will say between and exclusive. But last time, a few years back, O levels, the answer key was exclusive. Okay, that's why just now I say by default it is exclusive lah. But there are schools, including this one over here, this is a school question, okay, when they use the word between, the answer is actually inclusive. That's why it's very subjective. Please make sure you ask your school teachers the term that they are using in your particular school, okay? Okay, extra rotation, we mentioned this before. So take note, there are answers that can go beyond the first positive rotation, beyond the first negative rotation. Okay, so just make sure you understand, okay, how many rotations you need to see. The number of rotations you need to see, or the positive, whether you need to see whether is it a positive rotation or negative rotation, is dependent on the range over here. Okay, if my answer here, if my question here, sorry, says that x is actually smaller than 0 and bigger than negative 2 pi, it means that your answer is actually in the negative rotation. Can see that? So you should be looking at your negative cycle, the first one. So it depends on this range in the question, whether you need to see your answer goes in the negative cycle or in the positive cycle. If the range is, okay, if the range is something like this, it means that you need to go into your positive cycle twice, because this one is technically 360 degrees times 2. So you're completing the positive cycle twice. So how many rotation is dependent on the range given in the question. That's why this is the most important thing when you start the question. You make sure you're looking at the correct range. Then after you look at the correct range, you simplify the question. The next important thing you need to do is make sure you're looking at the correct quadrant. This question over here, there is no quadrant involved. Why? Because it's 0. Okay, 0 is not a negative number, it's not a positive number. So it's not exactly either on the first or all the way, it's not exactly in the first, second, third, or fourth quadrant. It's technically lying on the x-axis. Okay. So yeah. So this is what the point number 3 is saying, the extra rotations. Now we have finished the concepts, okay? But this page, I feel that is useful, okay? You guys can copy down if you need to. But what have we covered so far? We have covered the concepts of trigo, but at the same time, I have also covered the common type of questions that are tested. So the types of question in trigo, generally, there are questions that fall outside this common trend, okay? Some thinking outside the box question, okay? But these are the common question. The first type of question is finding the ratio. Okay, finding the ratio means they give you sine A, maybe equals to 3/5. Then they ask you, what is cosine A? Okay, they are not asking you for A, they are asking you for cosine A. So they are asking you for a ratio. This is the first type of question. The second type of question is your proving of trigo identities. They give you this super complicated looking trigo expression. Then they ask you, prove that, left-hand side equals to right-hand side. This is another common question. And how do you deal with these questions? We mentioned just now already. You need to bring in your trigo formulas, your trigo identities. The third kind of question is your graph-related question. I'm sure you have seen this in school by now, okay? You need to sketch the graph given the formula. But another type of question that could come out is they give you the graph shape, okay? Or they give you information on the graph. Then you need to deduce what is the period, what is the amplitude, what is the maximum point, what is the minimum point. Okay, so basically graph inference question. There's your sketching and there's your inference question. Okay, maybe I shouldn't put formula. I say infer graph cube. Okay, more clear cut. The next type of question is your solve for the angle. It's very different from the first one, finding ratio. Solve for the angle, we have already did some examples just now. Okay, it's the question that asks you, oh, find the value of x, find the value of theta. They are asking you to find the angle specifically. How you do this kind of question, solving for the angle, usually, okay, there are a few ways to do it. You can bring in your R formula. Okay, you can bring in your quadratic equations and factorization method. Just now we saw, right? We need to factorize certain equations. Okay, and we also could maybe need to bring in our trigo identity. So these are the things that you maybe need to bring in to solve the question. Okay, then the last type of very common question is your R formula. Part 1, they will give you this complicated figure. Then they ask you to prove this certain statement. Then after that, part 2, they will ask you to, using R formula, rewrite the statement in this particular format. Then part 3, they will usually like to ask you, find the maximum value, find the minimum value. Okay, these are very common questions, and I'm sure most of you have already covered it by now. Okay. So if you need to take a screenshot of this, go ahead. Okay, if anyone has any questions, feel free to write in the chat box. And then now we will be covering, because we only have one topic today, so we have time to cover the supplementary questions. Feel free and go ahead to do the supplementary questions on your own as I'm going through. Okay, it's always good to do it on your own first, actually. The first question I'll be doing is supplementary question 1. This is your typical graph question. Okay, it is your graph inference question, because why? The graph is already given. You are asked to, get the formula, find certain values, blah, blah, blah. Okay. Part A, they ask you to explain why is B equals to 2. Okay. B, what does B means? Okay, do you all need foolscap or something? If you all need foolscap, those physically, feel free to take some and pass it around. Okay. Question 1, explain why B equals to 2. Ask yourself, what does B affect? Okay, B only affects the period. So how do you explain why B equals to 2? You should be focusing on the period. What kind of graph is this? This is a cosine graph. Even if the question never tell you it's a cosine graph, you should know it's a cosine graph, because it has the typical cosine graph shape. Okay, so how do you explain why B is equals to 2? The period of this cosine graph is actually pi. Can you all see that? It is no longer 2 pi. So remember the formula that I taught you all just now? Period equals to 2 pi over B. So if your period is equals to pi, can you see this happens? Then very obviously, B is equals to 2. And you have explained why B is equals to 2. Okay. This is part A. Part B, the graph is repeated twice in 2 pi. Yep, we can already see it. They ask you to find the amplitude of the graph. Okay, I hope you guys can remember there is something that I taught you all just now to help you find the amplitude of the graph. Do you have the minimum value of the graph? Do you have the maximum value of the graph? Okay, you do, right? If you can find the entire stretch, okay, can you find the entire stretch? It will be maximum minus minimum. You just need to divide it by 2. Then you can find the amplitude. So your amplitude is actually 11 plus 3 divided by 2, which is a 7. Okay, pretty straightforward question. This question is super easy. Okay, you close one eye, you should be able to do this. Then you can check your work. Okay, trigo question, if you can check, always check your work. How to check? Okay, you can actually, you need to use part C to check your work. Part C asks you to find the value of C. You know the amplitude is 7. Okay, so it stretches out upwards and downwards by 7 units from your equilibrium line. C is your equilibrium, right? So if you know your maximum is 11, how to get equilibrium? You take 11 minus 7. Okay, Then how do you check your work? If you use maximum point to get C, you use minimum point to check your work. Because 11 minus 7 gives you an equilibrium point. But at the same time, your minimum point, okay, your minimum point, you plus 7 units, you will also get back to your equilibrium line. So there are two ways you can do it. Therefore, there is definitely a method for you to check your answer. Can see that? Always check your answer when you can. Okay, for those of you who are done, the next question I'll be going through is question 2. So go ahead and try it on your own if you want to. I'll go to question 2 shortly. Okay, question 2, very complicated looking workings. Okay, question 2A, they ask you to, okay, don't look at the answer key first. Listen to what I have to say first, because what I have to say is going to be tips and tricks to help you do a proving question. Question 2A, they ask you to basically prove this particular thing. Okay, they ask you to prove this particular statement. For a proving question, always start on the more complicated side. What do I mean by more complicated side? Okay, literally the side that looks more complicated, okay? It's very obvious the left-hand side is more complicated than the right-hand side, right? There's so much more things going on here than here, okay? So naturally, this question will start with the left-hand side. There are questions whereby you start on the right-hand side, okay? So take note, it's not always by default on the left, it's by default you start on the more complicated looking side. The more complicated looking side is also the side that you can apply more formulas to. What do I mean by formulas? Formulas is like your Pythagoras, identity, your Pythagorean identity, your double angle formula, your addition formula, whatever not. Okay, clearly for this question, this one is going to be more complicated. And could you also apply more formulas to this? Potentially, yes, because this one is technically equals to, you can use your sine square plus cosine square equals to 1. This one you can convert it to your secant square. This one you can convert it to your cosine square again, right? So naturally this side, there's more opportunity for you to apply formulas. At the same time, your sine square, you can also convert, sorry, not sine square, give me a moment. Your tangent square x, you can also convert it to sine square sine square x over cosine square x. Okay, this is also a formula. It is also technically an identity you can use. So the next thing is, okay, there's so many identities we can think of, but which one should we use? Okay, that is the next important question. Okay, don't apply the formulas blindly. Okay, it doesn't mean if you see a secant square A, you must convert it to a tangent square A using your Pythagorean identity. No, you must always ask yourself, okay, you must always ask yourself, what is your end goal? Your end goal for this question is to convert this into this. You want a cotangent, which is technically 1 over tangent, right? Do you think transforming this into a secant square x will be beneficial? No, you could transform it to a secant square x, but it is not going to be useful. So always tell yourself, yes, start on the more complicated side, start on the side that you can apply more formulas and identities to, but do not blindly apply them. You could get the answer by luck by blindly applying them, okay? You could, and that's what a lot of students do. They just blindly jump all the formulas, right? Then they get the answer eventually. But it is not the most optimal method. You will find yourself going in circles trying to do guess and check to prove the identity. So always apply formulas that you know that will bring you closer and closer to the other side. Okay, and then usually there is more than one way to do a proving question. So my answer over here might not be your answer. Okay, there's usually more than one way. So this question, let's look at this. Okay, I wrote this. Why did I write this? Why did I write this? It's because I'm trying to make this and this side look as similar as possible. Then I start identifying formulas I need to help me get the left-hand side to equal to the right-hand side. So I want a cotangent square at the end of the day. But technically, it means I want a cosine square over a sine square at the end of the day. So do I want to eliminate this? Maybe not. But do I want to eliminate this? Definitely. So how would I eliminate this? I would convert my tangent square x to a sine square x over cosine square x. Why not secant square x? Because it literally doesn't bring anything to the table. Like, what is it going to do? It's just going to complicate things. Okay, so that is my first step. So after I got the step, okay, I will multiply throughout by cosine. Okay, why do I multiply throughout by cosine? Because it's just in the way lah. I just want to like move it away first. Then once I get this, okay, the idea is still the same. You want a cosine square x over sine square x at the end of the day. Can you see that there might be like common factors you can take out? Your sine square is a common factor. Why do I want to take out my sine square? Because, okay, I don't want a sine square in my, I don't want a sine square in my numerator. So notice all my steps there's a reason to it. I'm not randomly cancelling things. At the end of the day, I want this, okay? I want this at the end of the day. This is in the way. I want to cancel it. Therefore, I take out sine square x as a common factor on my denominator as well. Then I can cancel it. Then if I cancel it, can you see technically I only have a cosine square x over a 1 minus cosine square x? I'm not at my answer yet, but I am super close. Okay, why am I super close? Because this thing, can you convert it to something? Okay, can you convert this to something? Have we learned any formulas that can convert our cosine square into sine square? We have, right? The Pythagorean identity. So this technically is just simply equals to sine square, okay? And we have already proven our question. Please make sure you write the word proven. Okay, there are schools that penalize when you don't put the word proven when it's a proof question, or shown if it's a shown question. So please make sure, yes, you get the answer, but also write this down, okay? Presentation marks. Yeah. So it's not about getting the answer that is important, okay? It's about the thought process. Notice how I think when I put every single step. I'm not randomly plugging in formulas. I always start at the more complicated side. I want to get my right-hand side. All the formulas that I plug in, there's a reason for it, because it will help me get closer and closer to the right-hand side. Okay, part II. They say, hence, solve this particular equation, leaving your answers in terms of pi. Every time when you see the word in terms of pi, or if you see leaving your answers in exact, you must think of your special angles, because your special angles are the only angles that give you exact trigonometric ratios. Okay, so every time you see in terms of pi in exact, you tell yourself, probably special angles are involved in this question. It's a hence question, so basically they gave you a hint already. You need to go and write this statement first. Okay, write this statement first. And remember, because you're solving for what? You're solving for x. So you should always write this thing to make sure that you are looking at the correct range. So you are solving for cotangent square, x equals to 3. Okay, how are you going to continue with this question? Naturally, you will want to square root both sides, right? Because you want either a sine, cosine, or tangent. Because your calculator only got sine, cosine, tangent. If you square root both sides, you will get a cotangent. And technically, you can get a tangent lah. Okay, but you're square rooting a square number. So what does it mean? Your answer have plus minus. Okay, so it will be hold on. think there's a, yeah, there's a plus minus. I didn't square root first. I convert it to tangent first, and then I square root and I get a plus minus. Okay, your steps can differ from mine, but at the end of the day, you should be getting tangent x equals to square root 3 or square root, 1 over square root 3 or negative 1 over square root 3. Okay, how do you continue from here? How do you continue from here? Your answer, your question is in radian, so your workings should also be in radian. Do not do your workings in degree, yeah? Okay, I know some schools, okay, they say that if the question is in radian, feel free to put your workings in degree and then final answer back in radian. Okay, but that's not ideal. Ideally, if the question is in radian, all your workings should be in radian. If the question is in degree, all your workings should be in degree. Okay, because if the question is in radian and your workings is in degree, you could be penalized, even if your answer you convert it back to radian. So 1 over 3, okay, this thing over here and this thing over here, okay, they actually gives you answers in different quadrants. Can you see that? This value is giving you an answer in the second and fourth quadrant. This value over here is giving you the answer in the first and third quadrant because tangent ma, okay? But do they both have the same basic angle? They do, okay? Because your basic angle doesn't require the negative sign. This one, the basic angle is tangent inverse 1 over 3 square root 3. This one also, okay? So therefore, they have the same basic angle. But what is this basic angle? Can anyone tell me? Take note, the question requirement is leaving your answer in pi. Okay, does 1/3 look very familiar? Sorry, 1 over square root 3 look very familiar? Okay, it does. 1 over square root 3 is one of your special angles. If you key this into the calculator in radian mode, your answer will be very ugly. Okay, but because you recognize that 1 over square root 3 is a special angle, it's actually pi over 6, 30 degrees. Okay, so this is your answer. This one and this one comes, this one and this one comes from here. This one and this one comes from here. If you don't understand what I'm saying, let me know. Usually your answers, you will give in ascending order. Okay, so you'll give from smallest to biggest. Therefore, I arrange it like that. Okay. Anyone know how to check their answer for this question? Okay, how you can check your answer for this question is you are solving for x, right? So naturally, you want to check whether your x values are correct lah. So what you do, you just sub it in, okay? You just put this into your trigo function. Put it in, put it in, put it in. You should either only get 1 over square root 3 in your calculator or negative 1 over square root 3. If you don't get 1 over square root 3 in the calculator for your answers over here, then something is wrong. This is how you check your work. Trigo question more often than not can check your work one. So if you have the time, please do it. Okay, now, okay, we probably only have time for one more part, which is part 2. Okay, this question, part B, they ask you to find all the angles which satisfy this particular formula. Can you see a 2x and an x involved? Okay, you see a 2x, you see a x. Immediately you should think of something. You need to bring in your double angle formula. Okay, no brainer one. By now it's very obvious already. Last time maybe not very obvious lah, but now it is, okay? Because you see a 2x and an x. If you see both 2x, like if this and this is 2x, then maybe you don't need to bring in double angle formula, okay? It's only because you see a 2x and an x, there's some doubling happening or some halving happening. Then you need to bring in your double angle formula. So double angle formula for cosine 2x got how many? There's 3 of them, right? But which one should you bring in? You bring in the one that doesn't complicate the question. There is only one that doesn't complicate the question because the other two contain sine square. Can see that? So you should bring in the one that doesn't contain the sine square. Okay, you should bring in this particular formula. So just bring it in, substitute it, okay, and you will get this equation. Please take note to write this down again, because you want to make sure you get every single solution. Okay. Okay, then after you get this, you realize that if I simplify it, it simply looks like a quadratic equation already. Can see that? Okay, remember just now there was this thing in the notes that says substitution. Okay, if you are unable to solve this quadratically, use substitution. So sub cosine x as u or k. But if you can factorize these in cosine, go ahead. Okay, the answer over here, I factorized it using cosine, but it might not be straightforward to some of you guys. Okay, remember to always give your factorization table. Some schools, they use the box method. I forgot what this method is called, the one that I'm using. Okay, but please include it in your workings. This one confirm O-level, they look out for it. Okay, your school teacher might not emphasize that this is needed, but I'm telling you, O-level Cambridge examiners are looking out for this. Okay, so please put this table, especially for your O-levels. Don't be lazy. Okay, 1 mark is a lot. Okay. So if you cannot factorize these, if you don't know how to factorize this, not to worry, you use substitution. So let cosine x be u. Then 6u squared minus 5u minus 1 equals to 0. Then you just key into your calculator. Okay, please, if you don't know how to key this in your calculator, let me know. Okay, for Casio calculator is equation mode, polynomial degree 2. For sharp calculator is mode 2. The calculator will throw out 1 and 5 over 6. Okay, so it means that it will be u minus 1, 6u, sorry, not 5 over 6. Hold on. There's a careless mistake here. Sorry, this one is not 5. This one is 1. It will affect my solutions over here. Okay. So u equals to 1 or negative 1 over 6. And then, but we are not solving for u, remember? So we have to write back cosine x equals to 1 or negative 1 over 6. Okay, there is a careless mistake here. See, even I make mistakes, but see, check your work, important. So this one is a 1. My alpha will be affected. Hey, don't just copy the answers blindly. Make sure you really know why my alpha is a certain value. Okay. Take note of my presentation. Notice how I am leaving it in 3dp as my alpha is 3dp. Your intermediate workings should always be 2dp or 2sf more than your final answer. Okay, so because final answer in degree is 1dp, I will leave my intermediate workings in 3dp. But because it's an intermediate working, you do not necessarily need to round down or round down. So what I like to do is I just cut it at the 3rd dp. Okay, because some of you might be wondering, why is it a 40.05? Why not a 406? Okay, that's the reason, because I'm not rounding it off. I'm just cutting it at that point. Okay, and because this value is a negative, it is in your 2nd and your 3rd quadrant. Okay, then this one over here is a 1. Okay, if it's a 1, right, remember you can use your cosine graph. You don't even need to key into your calculator. Cosine 1 from the cosine graph, we know that it's going to be this point and this point. Therefore, x is equals to 0 and 360 degrees. Can see that? Okay. So yeah, leave your answers in, usually you leave it in ascending order. If there's any calculation error, let me know. And this is how you would do this question. If you cannot, same thing, if you cannot see the factorization of a cosine square, please use the substitution method to make your life easier. Okay. One last part. Okay. This question, if I change it up, hold on. Let me copy the page. Okay, this question, if I change it up, okay, I know that some of you are still copying, so I'm trying my best to leave the solutions at the bottom visible. Okay, if I change the question, now I put a 2 here instead. Okay, how would you guys do it? If there is a 2x, cosine 2x or both, you no longer need to bring in your double angle formula. Okay, it's not like a sure thing because both of them are 2x anyway. So what you will do is you will first of all, yes, very good. Okay, someone answered online, which is exactly what I need to emphasize. You need to change the range. Okay, this is very, very important. The reason why I kept emphasizing that you need to write this range over here is because for questions like this range is very important. Okay, how would you do this question? You won't bring in your double angle formula because why? Both of them are doubled. There is no doubling effect because technically they are the same thing. Okay, but the question is still trying to ask you to solve for x. Every time when the question asks you to find an angle, it is x lah, not 2x, not 3x, not half x, it's just x. Okay, you will make your life easier by simplifying this first. So what you will do is you will simplify this part. You will get negative 2 cosine 2x equals to negative 2. Can see that? Then in a way, cosine 2x is equals to 1. Can see that? But this question, are you solving for x directly? No, you are solving for 2x. Then after that, you solve for x. Because you are solving for 2x first, you need to change the range. How to change the range? Because from x to 2x is literally times 2, right? Okay, so your range will be 720 and 0. Okay, because you're literally multiplying by 2. Why do you need to change the range? Because, okay, if you don't change the range, you will miss out solutions. Can you see that? If you solve for 2x, but you're using the range of x, you will miss out like 1 cycle worth of solutions. So that's why rule of thumb is always write this for every single question. Like just now that question, we don't need to change the range, right? But just write it, okay? Put in, make it a habit, write it down so that you don't miss any single solution. So cosine x equals to 1, okay? Same thing, 1 is your special value already. You can get it from the cosine curve, right? Okay, hold on. Yeah, you can get it from your cosine curve. So you just get it from your curve accordingly. You solve for 2x, and then after that, you divide by 2 and make sure, you divide by 2 to get the value of x. Okay, then that's all for today. Make sure when you get 2x, you don't just stop at 360 degrees. Okay, you go into the second cycle if needed. Okay. Okay, before you guys go, same thing. Okay, I need some help on feedback. Okay, and if you are interested, if you like our revision sessions, not just for A Math, okay, for any other subjects, here are some information that we have. So yeah, these are if you need to leave, feel free to leave. Okay, but I need you guys to help me do a survey later. It's at the back of the slides. So these are the information on our regular lessons. So what notes you have, right, is usually what we use for our regular tuition sessions. Okay, so if you like the notes or if you like the session, yeah, this is kind of how regular tuitions will be like. And we provide worksheets, mock exam papers, and consultations availability upon request. Okay, so there are makeup lessons. If you cannot attend the lesson, it will be via Zoom, and you can receive the recording. If you cannot make up for any lessons, we will record the lessons down. And then we have welfare lah, because today is session 1. Session 2. If you attended session 1, you will get a goodie bag. Okay, so some of you received the goodie bag, but unfortunately we ran out today. So we have welfare and snacks and stuff like that lah. Yeah, and if you are interested, okay, no obligations, no nothing. If you are interested, we have some like sign up free lessons and early bird rates or something. Okay. So yeah, and yeah, this is the one that is the most enticing lah. If you are a current student with OVERMUGGED, this is more relevant to you. Okay, so if you are interested, you can if you are current OVERMUGGED students, you can refer your friends. Okay, and these are the benefits. It's quite crazy. Okay, it's $100 per person if you manage to refer someone, and there are like free AirPods for 4 or more. Okay, I don't even have AirPods Pro. So yeah, that's only if you're interested. And yeah, resources at your disposal. The QR code, right? It contains the resources, but there are also other resources as well. You can find them on our OVERMUGGED page. It's not just for math. There are many subjects that has resources online on our website. So please utilize it. It's there anyway. Okay. So these are my group tuition classes. If you are interested, okay, next the Sec 3 will be a Sec 4 next year. Then the Sec 4 will be JC next year lah. Okay, and yeah, the one that I need you guys to help me with is this particular survey. So yeah, if you have done it before, you can do it again. So you just need to scan this QR code and give your feedback. So this feedback will be helpful to us to help us like improve future events. So this is just one of the many events we have hosted. This is our Sec 3 end of year. In June, we had a crash course for Sec 4. Then last year, we had a an event for IP. So it's like we always have different events. So yeah, any feedback will be valuable. Thank you. Yeah, if you all don't have any questions, feel free to leave. If you have any questions, you can stay back and ask me what's going on with the notes. You. Okay, those online, if you have any questions, feel free to write down in the chat box. Questions can be math related, can be tuition related, whatever. Okay. Yeah, those attending physically, if you need the revision kits, feel free to take one before you go. Okay, thank you.